Hey there, future math legends! Welcome to day 1 of Shape School. I'm so hyped because today we're starting our epic slicing adventure. We're going to look inside shapes like we have X-ray vision. Get ready, it's going to be hilarious and mind-blowing. All right, check out slide 1. We're diving into module 2, cross-sections of 3D shapes. Now, don't let the big words scare you. A cross-section is just what you see when you slice something open. Think of it like a shape's secret internal identity. We're going to uncover these secrets one by one. It's like being a shape detective, and I promise no shapes were harmed in the making of this video. Well, maybe a few oranges, but they were delicious. Look at slide 2. We've got a whole lineup of shape suspects here, A through J, but today's VIPs are C and F. Why? Because they are prisms. Notice anything special? They've both got two bases that are exactly the same. It's like a shape sandwich with the same bread on top and bottom. C is a quadrilateral prism, fancy talk for boxy, and F is a pentagonal prism. They're the double-deckers of the geometry world. Count them, 1, 2 bases. Moving on to slide 3, say hello to H and J. These aren't prisms, they're cylinders. They're smooth, they're round, and they also have two bases, but these bases are perfect circles. Think of your favorite soda can or a roll of paper towels. That's a cylinder in the wild. They're like the cool, curvy cousins of prisms. Just like C and F, they've got that top and bottom base thing going on. Two bases for the win. Slide 4 brings us the pyramids. Look at B and D. They're much pointier than our previous friends, right? That's because they only have one base. Everything else just zooms up to a single point at the top. They're like the ancient tombs of Egypt, but way more portable. B is a pentagonal pyramid, and D is a triangular pyramid. They're like, nope, I only need one base to be fabulous. Just one. Don't try to stand them on their heads. Slide 5. It's time for cones. Check out E and I. These are basically the pyramids of the round world. Just like pyramids, they only have one base, but their base is a circle. Imagine an ice cream cone. The best kind of math, obviously. If you flip it over, it stands on that one circular base. They're sleek, they're pointy, and they're definitely only rocking one base. 1 is the magic number for cones. And finally, for our shape identification parade, slide 6 gives us the spheres. Look at A and G. How many bases do they have? 0. Zip, zilch, nada. They're just perfectly round all the way around. They're the soccer balls, the oranges, the planets of geometry. They don't have a flat side to stand on, so they just roll with it. Literally. No bases here, just 100% roundness. They're basically the shape version of a mic drop. Now, let's get back to that big question. What is a cross-section? Look at slide 7. Mom's brought home some fruit. She takes an orange and, hi-ya, slices it right down the middle. See that flat, juicy face on the inside? That's the cross-section. It's the surface you get when you cut through a 3D object. It's like seeing what's actually going on inside. And in an orange, it looks like a beautiful sunburst circle. Slide 8. Let's try it with an apple. Mom slices it vertically this time. Look at that cross-section. It's not a sunburst like the orange. It's got that classic apple shape with the seeds in the middle. Every time you slice a fruit, you're doing math. You're creating a cross-section. It's the two-dimensional shape that's hidden inside the three-dimensional fruit. Math is literally everywhere, even in your lunchbox. Slide 9. This one is the coolest. The star fruit. Look what happens when you slice it. The cross-section is a literal star. How cool is that? These faces we get from cutting through the shapes are officially called cross-sections. If anyone asks you what you learned today, just say, I learned that star fruit are math stars. It's the flat face that reveals itself after the cut. Star fruit really know how to make an entrance. Slide 10. Let's get technical. If we take this quadrilateral prism, it looks like a tall box, and we cut through it horizontally, what do we get? Look at the shape of the base. It's a square. And look at the shape of the cross-section. It's also a square. It's like the shape just duplicated itself. When you slice a prism like this, the cross-section is the same as the base. It's like a geometric magic trick that always works. That's all for our first lesson. We've identified our shape suspects and learned the secret of the cross-section. You're already math legends. Come back for video 2, where we'll slice through even more shapes and see what other secrets they're hiding. See ya! Welcome back, Shape Legends! Ready for more slicing? Today, we're not just using knives, we're using water. It's time for the ultimate water trial. We're going to see how water surfaces can teach us everything we need to know about cross sections. Let's dive in. Check out slide 14. We're starting an inquiry and investigation. Imagine you have transparent containers in the shape of prisms or cylinders. We're going to pour water into them at different levels. Why? Because the surface of the water acts just like a horizontal cross-section. It's a clean, non-messy way to see the inner face of these shapes. Think of it as shape science. Slide 15 shows our first experiment. We've got a quadrilateral prism. As we pour water in, look at the surface. Whether the water is low, middle, or high, the surface is always a square. And look at the base of the container. It's also a square. The shape doesn't change no matter how much water we add. It's like the square is just rising up through the container. Next up, slide 16, a triangular prism. Watch the water surface as it rises. What shape is it? A triangle. And what's the base? Also a triangle. It doesn't matter if it's a tiny puddle or almost full. That triangle stays the exact same size and shape. It's like a geometric elevator. The triangle just keeps going up and up. Math is so consistent, isn't it? Now for the smooth one on slide 17, the cylinder. We pour the water and the surface is a perfect circle. Low level, circle, high level, still a circle. And yes, the base is a circle too. Sensing a pattern here? Prisms and cylinders are like the superheroes of consistency. Their slices or water surfaces never change. They just stay true to their bases. Slide 18 is where we use our detective brains. What's special about these cross sections? Drumroll, please. When a prism or cylinder is cut horizontally at different positions, the resulting cross sections have the same shape and size as the bases. It's the golden rule of prisms. They're uniform. They never get wider or narrower as you go up. They're just perfect clones of their bases. Time for some practice on slide 19. Look at this quadrilateral prism. If we draw the cross-section resulting from that horizontal cut, what should we draw? That's right, a rectangle or square to match that base. It's like tracing the bottom of the shape and just floating it up to where the cut is. Easy peasy, shape detective. Slide 20, a triangular prism. Imagine that horizontal plane slicing through. What shape pops out? A triangle. It's like the shape is saying, I'm a triangle all the way through. Draw that triangle in the space provided. Remember, it has to be the same size as the base. No shrinking allowed in Prismland. Check out slide 21, the cylinder. If we slice it horizontally, our cross-section is a circle, just like the base. Draw a perfect circle to match. Cylinders are so satisfying because they're just circles stacked on top of each other until they reach the top. It's like a tower of giant coins. Check out slide 22. A pentagonal prism gives us a pentagon. It's like a shape mirror. No matter where you cut, it's 5 sides all day. And slide 23 shows the hexagonal prism giving us a hexagon. It's math magic. No matter how many sides the base has, the horizontal cross-section will have the exact same number. Mastered. That's it for the water trial. We've proved that prisms and cylinders are perfectly uniform. Next time, things get a bit more pointy as we look at pyramids and cones. Don't go anywhere. The slicing continues in video 3. See ya! Hey there, math explorers! Welcome back to Shape School. Today, we're dealing with some very pointy characters. We're moving from prisms to pyramids and cones. If prisms are double-deckers, these guys are more like math party hats. Let's see what happens when we slice them. Slide 24 is our preview. Before we slice, we have to know our base. Shape 1 is a pentagonal pyramid. Count those sides on the bottom. 1, 2, 3, 4, 5. And shape 2, it's standing on a triangle. Knowing the base is the first step to becoming a cross-section master. It's the foundation of everything. Look at slide 25. We've got a quadrilateral pyramid. We slice it horizontally and, surprise! The cross-section is a square, just like the base. But wait, is it the same size? Nope. It's a bit smaller. It's like the base is the parent and the cross-section is the kid. Same shape, just a younger, smaller version. Slide 26 shows the triangular pyramid. Slice it horizontally and you get another triangle. It's a mini-me of the base. Pyramids are very loyal to their base shapes. They just can't help themselves. Whatever is on the bottom, you'll find a smaller version of it on the inside. Isn't that sweet? Slide 27, the cone. Slice through this party hat and what do we see? A circle, just like the base. Again, it's smaller than the bottom circle. Cones are basically just stacks of shrinking circles. It's like a geometric funnel. Round on the bottom, round in the middle, and eventually just a tiny point at the top. Back to the water. Slide 28 starts our second investigation. We're going to pour water into pyramid and cone-shaped containers. This is where things get really interesting. Watch the water levels carefully. We're looking for patterns in the shapes and the sizes. Get your detective hats on. Slide 29. As we pour water into the quadrilateral pyramid, the surface is always a square. But look, as the water level goes up, the square gets smaller and smaller. It's shrinking. The higher the water, the less room there is. It's the opposite of a prism, where it stays the same. Pyramids are shy. They get smaller as they go up. Slide 30, the triangular pyramid. Low water level, big triangle, middle level, medium triangle, high level, tiny triangle. The shape stays a triangle, but the size is on a diet. It just keeps getting smaller and smaller until it reaches that pointy top. It's like a shrinking geometric elevator. Slide 31, the cone trial. We pour the water and we see shrinking circles. Big circle at the bottom, tiny circle at the top. It's like the cone is running out of space. This is the big difference between prisms and pyramids. Prisms stay the same, but pyramids and cones are shrinkers. Remember that for the exam. Slide 32 gives us the conclusion. When a pyramid or cone is cut horizontally, the cross-sections have the same shape as the base. But, and this is a big but, the farther up it is cut, the smaller is the cross-section. Think of it like a mountain. The base is huge, but the higher you climb, the less space you have at the peak. Practice time, slides 33, 34, and 35. For the quadrilateral pyramid, draw a square cross-section. For the triangular pyramid, draw a triangle. And for the cone, draw a circle. Just remember to draw them smaller than the base if the cut is near the top. You guys are drawing like pros already. Finally, the size game on slides 36 and 37. Look at the two cuts. Which one is larger? The one lower down, of course. Position A is near the top, so it's small. Position B is lower down, so it's large. It's all about how much room the shape has left. Lower is larger, higher is smaller. You've got this! We've conquered the shrinkers. Pyramids and cones are no longer a mystery. Next time, in video 4, we're going to look at the most perfect shape of all, the sphere. It's going to be a real ball. See ya. Hey, Shape Legends! Welcome back. Today, we're dealing with the most perfect, rolliest, and arguably the most delicious-looking shape of all, the sphere. Think soccer balls, oranges, and, well, mostly food. Let's see why the sphere is the absolute GOAT of geometry. Slide 38. Before we talk spheres, we need a quick circle checkup. Every circle has a center, and the distance from that center to any point on the edge is the same. That's called the radius. It's like the spokes on a bicycle wheel. They're all the same length to keep you rolling smooth. Remember this same distance rule. It's going to be a huge deal later. Look at slide 39. We take our sphere and slice it horizontally. What shape do we find hiding inside? A circle! It's perfectly round, just like our preview. No matter where you cut a sphere horizontally, you're going to find a circle staring back at you. It's like the sphere's DNA is just circles all the way through. But wait, slide 40 shows the sphere's secret superpower. What if we slice it diagonally, or vertically, or upside down while standing on one foot? Guess what? It's still a circle. The cross-section of a sphere is always a circle, no matter which way you slice it. It's the only shape that's this dedicated to being round. Talk about commitment. Slide 41 asks a big question. Are all these circles the same size? If we cut in the same direction but at different spots, the shape is always a circle, but the size changes. Just look at those slices. Some are tiny caps and some are huge. It's like a family of circles living inside one big sphere. They're all the same shape, but definitely not the same size. Water trial time on slide 42. We pour water into a sphere container. Where is the water surface the largest? Look closely. It's right in the middle, up to the equator of the sphere. That's the MVP of slices, the largest possible circle you can get. Anything higher or lower just starts shrinking again. The middle is the place to be. Slide 43 reveals the truth. If you cut a sphere into two identical halves, you get the largest possible cross-section. And here's the cool part. The center of that circular cross-section is actually the center of the whole sphere. It's the shape's inner heart. When you slice through the center, you're literally getting the heart of the math. Check out this model on slide 44. We've got a small ball and a bunch of plastic sticks that are all the same length. We're going to pierce them into the ball one by one until it looks like a math hedgehog. This isn't just for fun. It's a high-tech demonstration of how spheres are built. Every stick is a radius, and they're all identical. Slides 45 and 46 bring it all home. Imagine a curved surface wrapping that stick model. That's a sphere. Every stick tip touches the surface. This proves our big rule. The distance from the center of a sphere to any point on its surface is exactly the same. It's like a 3D version of our circle spoke rule. Perfect symmetry in every direction. Math in real life on slide 47. An egg cutter. Look at those two different cross sections of the egg. One is a vertical slice and one is horizontal. Even an egg, which is like a sphere's oval cousin, has its own secret cross sections. Next time you're making egg salad, remember, you're basically a kitchen mathematician. Slice with pride. Final practice on slide 48. If we slice this sphere in the direction shown, what should we draw? Say it with me. A circle. No matter the angle, for a sphere, the answer is always round. Draw that perfect circle in the space provided. You're officially a sphere specialist. Great job today, legends. That's a wrap on video 4. We've rolled through the sphere and learned its round secrets. In the next video, we're going to put everything we've learned to the test with some intense exercises. Don't go anywhere. The math marathon continues in video 5. See ya! Welcome back, math legends! You've rolled, sliced, and investigation-ed your way through the world of 3D shapes. But are you ready for the final boss? Today, we're testing your skills with some rapid-fire exercises and then summarizing everything so you can be the smartest person in the room. Let's go! Slide 49. Look at this triangular prism. If we slice it horizontally, which letter matches our cross-section? A, B, C, D, or E? Look at that base. It's a triangle. So the answer must be B. It's like looking in a mirror. Prisms never lie about their inner circles or triangles. Excellent start. Slide 50. A triangular pyramid. It's pointy, so we know it's a shrinker. But what is the shape? The base is a triangle, so the cross-section is also a triangle. That's B again. It doesn't matter if it's smaller than the base. It's still a triangle. Pyramid loyalty is real, folks. You're crushing this. Slide 51. The cone. Sliced horizontally. What do we see? Look at that circular base. It has to be A perfect circle. Even though it's higher up and a bit smaller, its identity is 100% round. Cones are basically the math version of a record player. Spin that circle. Slide 52. A quadrilateral prism. This one looks a bit different. It's like a lopsided box. But look at the base. It's a quadrilateral. So our cross-section must be E, that matching lopsided rectangle. Prisms are so predictable. They should really try being more mysterious. But for us, predictability means easy marks. High five! Slide 53. Which cutting position results in a larger cross-section? The one near the top or the one near the bottom? Remember the mountain rule. The lower you go, the more room you have. So the circle on the right, position B, is our winner. Lower is larger, higher is smaller. Simple as pie. Math pie. Slide 54. The sphere challenge. One cut is right through the middle and one is just off center. Which one is the heavyweight champion? The middle one, of course. We learned this in video 4. The equator is the MVP of slices. Position A takes the gold medal for the largest circle. Middle is always the biggest. Slide 55 is the radius riddle. Point O is the center. A and B are on the surface. If BO is 5 centimeters, how long is AO? Don't even reach for your calculator. Remember the bike spoke rule? The distance from the center to any point on the surface is the same. So AO is 5 centimeters. Boom! Math logic for the win. You guys are too fast for me. Time for the big wrap-up. Slide 56 reminds us, the face obtained from cutting a 3D object is called a cross-section. It's the secret interior world revealed. Whether it's an apple, a star fruit, or a geometry block, that flat face is the key. Don't forget the name. It's your new favorite math word. Slide 57, the double-decker summary. For prisms and cylinders, horizontal cross-sections have the same shape and size as the bases. They are the icons of consistency. They don't shrink, they don't grow, they just stay awesome. Remember, prisms, twins of the base, always. And the grand finale on slides 58 through 60. Pyramids and cones shrink as they go up. Same shape, smaller size. Spheres are always circles, no matter the angle, and the middle slice is the biggest. And remember that hedgehog. The center is the heart of the sphere. You've officially graduated from Slicing Academy. I'm so proud. You've mastered the slices. We've covered everything from basic fruit to complex sphere heart surgery. In our next and final video series, we're going to use everything we've learned for something truly sweet, making chocolate. See you in video 6. Bye! Hey there, math gourmets! Welcome to the sweetest part of Shape School. Today, we're not just slicing fruit, we're making chocolate. We're joining Haley and her classmates for a chocolate making class where the math is delicious and the cross sections are, well, edible. Let's get cooking. First stop, slide 61. Haley is preparing the chocolate. Look at that scale. The needle is pointing right past the 200 mark. If we count the little notches, where does it land? Bingo! 220 grams. That's a lot of chocolate. When you're measuring, always look at the unit, grams in this case, and the scale's precision. Math helps us make sure we don't run out of the good stuff. Slide 62. Haley's melted the chocolate and made 8 different pieces. Look at them on the tray. Our mission? Find the prism-shaped pieces. I see a cube, that's a prism, a cuboid, another prism, and a hexagonal prism. That's 3 pieces out of 8. So, prism-shaped pieces make up 3/8 of the whole batch. Fractions are just a slice of the total, and today, they're a very tasty slice. Slide 63 is a big one. Haley slices a cuboid piece. What's the cross-section shape? A rectangle. To find the area, we need the dimensions. It's 3 centimeters by 2 centimeters. 3 times 2 equals 6 square centimeters. Don't forget the square in square centimeters. It's 2D now. We've turned a 3D treat into a 2D math problem, and the result is a perfect 6. Slide 64. Holman is cutting a hexagonal prism chocolate horizontally. Which letter matches the cross-section? Count the sides of that base. 1, 2, 3, 4, 5, 6. It's a hexagon. So our answer is D. Prisms are so loyal. They always show their true base shape when you slice them. Holman knows his hexagons. Slide 65. A triangular pyramid chocolate. Slice it horizontally, and what do we get? A triangle. That's letter A. But remember what we learned about pyramids? Is it the same size as the base? No way. It's a shrinker. Same shape, triangle, but smaller size. Holman is becoming a cross-section master, and so are you. Phew, that's a lot of chocolate math. We've weighed, counted, and sliced our way through the first half of the exercise. In our final video, video 7, we'll finish the chocolate challenge and find out who gets the largest slice. Don't miss the grand finale. See ya! Welcome to the grand finale of Shape School. I'm so proud of you, math legends. You've sliced fruit, you've survived the water trial, and you've even started making chocolate. Today, we finished the mission. We're going to solve the final chocolate puzzles and find out who gets the ultimate largest slice. Let's bring it home! Slide 66. Holman is at it again with a cylinder-shaped chocolate. We slice it horizontally. Think back to our soda can rule. What's the base? A circle! So the cross-section must be B, a perfect circle. And since it's a cylinder, it's the exact same size as the base. Consistency is the secret ingredient in this chocolate. Draw that circle and give yourself a point. Slide 67, a pentagonal pyramid chocolate. This is a tricky one. Count those base sides. 1, 2, 3, 4, 5. It's a pentagon. So our cross-section is E, the pentagon. But wait, is it a big pentagon or a tiny one? Since it's a pyramid and we're slicing near the top, it's a shrinker. It's a mini pentagon. Same shape, just a smaller bite. Keep that thinking cap on. Slide 68, the sphere showdown. Jenna and Jordan have identical sphere chocolates. Jenna cuts near the bottom and Jordan cuts right through the middle. Who gets the larger cross-section? Jordan, of course. Remember, the equator is the heavyweight champion of sphere slices. It's the largest circle you can possibly get. Jordan is the big winner in this round. Sorry, Jenna. Slide 69, the final battle, the cone showdown. Jenna slices through the middle and Jordan slices near the top. Which cutting position results in a larger cross-section? Jenna takes the gold. In a cone, the lower you cut, the closer you are to that big circular base. The higher you go, the pointier and smaller it gets. Jenna gets the big slice this time, symmetry in math and fairness in chocolate. And that's it! You've completed the entire course. From oranges to chocolate, you've mastered the inner lives of 3D shapes. You are officially Shape School graduates and certified math legends. Go forth and slice through life with confidence. I'm so proud of you. See you next time for our next big adventure. Bye.